Hello. So in this video, we are going to start a new format of hypothesis testing. So the typical form is like this. So think about this hypothesis. As I mentioned at the end of the previous video, this hypothesis involves two parameters, but it has only one restriction. So then, can we apply the single hypothesis testing, or do we need to use the joint hypothesis testing? So like, for example, if you compare with this hypothesis, if you have this hypothesis, it is not about beta, so this hypothesis has two equalities on two coefficients. So in that sense, it is certainly a joint hypothesis, but this is somewhere in between the single and joint hypothesis. So let's discuss how we can handle this problem. I will introduce two different approaches to test for the hypothesis like that. The first approach is we are going to rearrange the regression equation so that those two coefficients become one. So it is a very clever idea, and then you can apply single hypothesis testing. The second approach is, it's actually maybe this is what you want. The second approach is that I don't know how to do that, but Stata knows that. Stata, even though you don't know how to handle that problem, but as long as you know what to write on Stata, if you know the command on Stata, then Stata can do this for you. So that's the second approach, and it's more kind of direct way to test the hypothesis. So let's talk about the first one first. So think about this regression model. You have outcome explained by x1 and x2, but you'd like to test this, whether beta 1 and beta 2 are the same or not. So there are two variables. You'd like to compare which is more important, or whether they are the same. So your hypothesis is an equality on beta 1 and beta 2 at the same time. So then, smart idea here is like this. Add and subtract beta 2x1. So beta 2x1 makes this, so beta 2x1 is a cross product. So the x1 term, the coefficient of x1 becomes beta 1 minus beta 2. But the second term, the third term, so the second regressor, is replaced by beta 2, so the same coefficient beta 2, but the regressor becomes x1 plus x2. Anyhow, beta 2 x1 here and beta 2 x1 here will be cancelled out, so there is no difference in the regression equation. So the regression equation is the same, but we are going to rewrite the equation using a slightly different notation. I'm going to define the new notation, new coefficient, beta 1 minus beta 2 as gamma 1, right? And I will define the new regressor, x1 plus x2, as w. The other guys like beta 2 and x1, beta 0, u, y are still the same. So by adding and subtracting something, we can change the coefficient, one of the coefficients and one of the regressors. So then let's see what we can do with this new regression equation. This is so then in the original equation, the hypothesis is about beta 1 and beta 2. But in the new equation, in the rearranged, transformed equation, this restriction, this hypothesis becomes gamma 1 equals to 0, right? So when beta 1 equals to beta 2, gamma 1, by definition, gamma 1 should be 0. So that is exactly, gamma 1 equals to 0 is the same equation as beta 1 equals to beta 2. So then now, as you can see, this is a single hypothesis. You know how to handle this. It is an easier It is a t statistic. You just need to calculate the t statistic. Then can we obtain the t statistic? Yes, you can, because what you need to do here is, so in the original equation, you have to, on theta, you have to say that regress y on x1, x2. But instead of that command, you need to say regress y on x1 and w. And w is defined in this way. So defining a new random variable like this is super easy. You can define a new random variable by x1 plus x2, then regress y on to a different pair of regressors. Then you obtain the estimate of gamma 1 and also standard error for that, and then t statistic and p-value are automatically calculated. So it will be very easy. And if you estimate both models, literally they are the same thing. However, the only difference is these two guys. So when you compare the results from these two regression equations, their R-square must be the same, their predicted y values must be the same, and their residual distributions must be the same. So everything else must be the same except for this and this. So like say, for example, beta 2 must be the same, standard error of the beta 2 must be the same, of course beta 0 and standard error should be the same. So basically they are the same problem with just a small trick. So it's a very clever idea to simplify the test. This kind of method was not possible. So making a joint hypothesis, making a hypothesis about two or more coefficients into an equivalent hypothesis about one coefficient was not possible before when the hypothesis included two equalities. So two equalities cannot be summarized into one by simple linear combinations. So there was no rearrangement method when you need to handle multiple restrictions, multiple equalities. So this is a clever and new idea in a special case. And the second approach is just not doing anything, but let theta do the work. So then what you need to do here is you just need to know this command. Just type test student to teacher ratio equals to expenditure per student. So remember, we regress test score on these regressors, student to teacher ratio, expenditure per student, and percentage of English learners, and option robust option is given here, and test the coefficient of student to teacher ratio equals to the coefficient of expenditure per student. So then theta will do the rest. So super easy. So in that sense, you don't need to know the first method, but it's worth mentioning. And just in case if you don't remember what's the command, or if you use a different program, so you don't know the command, then this can be implemented easily, even if you don't know the command. So it's worth learning. Okay, so I will do a video here, the video here, and the next video is about confidence interval. So a generalization of the confidence interval is a confidence set. So we will discuss how we define confidence set for multiple coefficients. Okay, thank you for watching. I hope you to watch the next video soon.